Hello, hello, hello. Welcome back to my little corner of the internet. Um, I think the plan for me now is to start a weekly series going through interview technique that I'll be going with my individual students over. That was weird phrasing. Let me try that again. So once a week, I'm going to do some interview prep. And I thought for the first week, I would go through my interview experience, what I learned from that, and what I think anyone watching this will be able to apply to improve their interview experience. Now, interviews are always the most daunting part of any university application. I mean, obviously the tests are stressful, especially if you had to sit the ESAT, but tests you've done before, and for most people, interviews are something completely different that they've never tried before. And so it's a really high stress situation where you can't default back on your usual skills. So I thought I'd spend some time explaining what an interview is and why it's set up the way it is. So when you go through Oxford or Cambridge in particular, and I'm dealing mostly with like the math and the science side of things, or in the engineering, you are in groups of like hundreds of people going to these lecture halls, learning a bunch of new information, basically not really getting to ask many questions. You then you get these sort of like workbooks, sort of really thick with all the lecture notes in it, with a bunch of blanks in. So you have to go to the lecture to fill in all the blanks. That way they ensure attendance. And then at the end of each booklet, there are a bunch of problem sheets. And so it's your job at the end of each week to complete a problem sheet, hand it in to a supervisor or a tutor. And at that point, your work gets marked, you get it back, you get feedback. Now, that is the first part of the process. You've had any direct feedback. So you have to go to the lecture, process it passively on your own, get yourself to the point where you're already answering worksheets on your own before anyone really talks to you about it. And it's a really specific style of learning that they want to test that you're well suited for. So what they're really doing in an interview is two things. One, assessing how you're going to be in the environment, how well you're going to pick up on those abilities, how well you can grapple with new ideas and get yourself from A to B without much intervention. But also, typically the people doing your interviews are the very same people who are going to be your supervisors or your tutors for the first couple of years of your degree. So the way that the supervisions and tutorials work, so I've said that you kind of do your problem sheets, you hand them in, you get feedback. That's all done in college. So I had individual supervisors for math, for physics, for material science, and for chemistry, the subjects I did in first year. And in second year, when I dropped chemistry, I did math and physics and material science. I had individual supervisors for those as well. Those supervisors were all in college. Beyond that point, from like third or fourth year, when you specialize, your supervisions are all done department-wide. But for the first 2 years, they're done in college. And typically, the people doing your interviews are going to be those supervisors. So for me, I had 2 interviews. The first interview was a general skills math and science interview to test the breadth of my understanding. The 2 people who did that interview were my supervisors when I arrived in October. Sometimes they're not. So the person who did my second interview was much more of a big dog. His name was on the books and he's sort of known. He's got a sort of, he was too busy to sort of be supervising first years. So sometimes you'll have PhD students who will be your supervisors. And sometimes those very PhD students might be the ones interviewing you. But the point is they want to know that you are the sort of person they're going to want to be supervising for the next couple of years. So they're kind of going to put you to the test with their supervision style and checking to make sure that you are going to make the most of that opportunity. So that's kind of why they interview. That's why they give you these questions to sort of see how well you can handle new information, to make sure that if you get an offer, you're someone who's going to thrive in that situation with them doing exactly the same thing to you for the next 2 years of your life. And what I want to do now is discuss the specifics of my interview experience so you get a sense of what I can remember, how I moved through it, what I think went well, what I think didn't go well. And that will inform the sort of lessons I think you can pick up from it at the end. So what happened? Oh, also, one question that's going to get answered through this. No, let's talk about some specific skills that you need first. So the basics of how to do an interview. First things first, and this is the one everyone tells you, is speak everything out loud. If they want to make sure that you can handle the Cambridge system, they want to see what's going on under the hood. They want to see your ability to track a thought process and go, okay, well, I see this in the problem. It seems to be this and this. And if I put that together, then that seems to lead that way. And then, oh, wait, no, sorry, that was a mistake. I got to backtrack a little bit and then go this way and there. That's it. They want to see all of that you will be applying to those problem sheets, building your own understanding on your own. So you got to show them. You got to tell them how that thought process works. And that is very uncomfortable for people because you are very used to taking tests. And in tests, you sit there and you work silently, pen to paper. And you're very afraid of being seen to get something wrong. So a lot of people are very hesitant to speak an interview until they know what's happening. But a lot of the time, the point is that you don't know what's happening and you're supposed to be fumbling around and that might be wrong. And if that's wrong, then you spot it. And they will not hold it against you if you were wrong at some point on the way. It's all about the process rather than the destination. So as long as you get there at the end, you're kind of fine. So if anything, they like to see the kinds of mistake that you make, how you catch them, how you adjust. So speaking out loud always, very important. Silence is bad in an interview. But the second thing that I don't hear people talking about, that I really wish people would talk about more, is how to frame an interview. And the piece of advice I give to all of my students always is, it's a lesson, not a test. Because these people are running a sort of mock supervision with you, and a supervision is a lesson, this is your chance to experience that exact scenario. It is a lesson, not a test. In a test, you have already done your learning, and you write down pen to paper silently, and you're supposed to be getting it right, and if you're not getting it right, something's gone wrong. In a lesson, well, of course you don't know it. You've never seen it before. You start here, and you do some work, and you end up here. And you sort of fumble around a bit, but you get there, and you learn something at the end of it. And that is the way to frame an interview. The reason why that matters is because if you're stuck, and you're thinking, I'm not getting this, what am I going to do? In a test, that's bad. In a lesson, that's good. In a lesson, that means you're about to have your learning moment. And so, and working with the interviewer to get you to the end is not a bad thing. Needing intervention is not a bad thing. When I'm doing my interview prep, I'm specifically looking to push someone as far as possible until they require my help, to know that I've found the limits of their understanding. So needing help is not a bad thing in an interview, as I'll show when I talk about my interview experience. So those two things, talking out loud the whole time, making sure it's a lesson, not a test, to not get put off if something isn't going well. So let me tell the story. Oh, wait, and there's one more thing that everyone asks all the time, which is how much the personal statement matters. And the answer is, it depends. First of all, if you're going for Imperial, it matters a lot more. In fact, I'll start there. So because my Imperial interview was before my Cambridge interview. My Imperial interview, from what I remember, sort of 10 plus years on, is it was almost entirely based on my personal statement. So in my personal statement, I had written at one point, I'd mentioned Heisenberg's uncertainty principle because I quite liked it. And from memory, that was like my entire interview. So in fact, let me share a screen so you can get a sense of what I'm talking about. So we worked on a whiteboard, and he mentioned Heisenberg's uncertainty principle. And I explained, okay, well, that's the idea that you cannot simultaneously know both your position and your velocity. There must be some uncertainty in the mix. And he said, okay, how do you, let's apply this to sort of simple harmonic motion. Can you draw me a potential, a graph of potential in simple harmonic motion? So I went, okay, it looks like this. It's a nice sort of potential, goes as the, is proportional to x squared. So if that's the potential energy, and that's the displacement from equilibrium, I know that potential energy goes as x squared, it's going to be this sort of shape. He said, very good. And then he said, okay, so what if it was quantized? What if we were talking about energy levels of an electron, for instance? And I said, well, okay, then you can't take every specific value. You're only going to be able to have very specific values, very discrete values. So instead of being a curve like that, you're going to have specific energy levels. So I said you could have like that level, you could have that level, you could have that level, and you can have that level. And then he said, oh, well, are you sure about that zero? How would Heisenberg's uncertainty principle apply there? And I thought about it for a second. Because in my head, I was like, well, no, but on an energy level diagram, there's a ground state. That must be the ground state. That's n equals 0, right? But then he said that, and I thought about it. And I went, oh, yeah. Because if that was there and had no energy, well, then you would know exactly where it was, and it has no energy, so it's not moving. So you would know everything about it precisely. So that actually can't be ground level. It was something, I'm forgetting the specific details on this far on, but it was something like that. And he went, ah, yes, that's very good, very good. And that was the basis. Hold on, what did I do? How do I go back? That was the basis of my Imperial interview. So the entire thing was based on understanding from my A-level syllabus, the idea of quantized energy levels, the idea of potential curves. But it was all triggered by this one phrase that I'd included in my personal statement, talking about Heisenberg's uncertainty principle. And for my work with students, I get that a lot as feedback from Imperial. If you've mentioned something, you've almost indicated, get me here. Oh, hold on a minute. So if you've indicated in your personal statement that you know something, you're inviting them to ask you about it. They're going to challenge you. Any technical term that you've included, you've kind of said, oh, I'm able to understand this now. This is what it looks like when I teach myself something. Ask me anything. So if something is in your personal statement and you're applying to Imperial, make sure you're good to talk about it. And then a few weeks later, I had my Cambridge interview. And like I say, I had 2 interviews. So I was sitting in the waiting room, about to enter my first interview. The door opens. They let out the guy right before me. And then they say to him, next time, when you say you've read something on your personal statement, make sure you've actually read it. And I was like, oh, like I wanted to just die from secondhand embarrassment. Just wanted the ground to swallow him whole and get it over with. I was like, that's so uncomfortable. Because I could just imagine what it would be like if I was in that situation. Oh, the screen sharing isn't working. Oh, I'm so sorry, Joshua. Why is the screen sharing not working? I didn't even realize there was going to be a comment. Right, let me, first of all, not monologue so much. God damn, that was minutes ago. Let me actually, okay. Was it not? Let me have a look at the live stream. Yeah, so it is sharing. Okay, so I'll have you in a different tab. So hopefully that worked better. Joshua, if you're still here and you can't see it, and that's still an issue, let me know, because I think, yeah, it was when I started screen sharing, that's when I stopped seeing the YouTube window. So I stopped, great. So I stopped seeing your comment. So apologies for that. You can also leave a comment if you want me to explain again what is currently on the screen. But in the meantime, I'll sort of check for comments, but if not, I'll sort of keep going. So this was all the stuff for the Imperial stuff. So I'll stop sharing that and continue talking about like the Cambridge side of things. So in conclusion, for the Cambridge stuff, just for security, don't be that guy. Make sure if you've mentioned something that you've actually read it, that you're actually able to talk about it. then, so I sat down, and in fact, no, I'll start sharing screen again because I really want you to see the specific questions that I can still remember. So what do you think like the first question they would ask in a Cambridge interview is? So they sat me down and I'm thinking like, oh my God, this is going to be so intense. This is going to be crazy. What are they going to do? They've eaten that last guy to shreds. Like, I'm not going to cope. And he sits me down and he says, sketch for me the following graph. And I was like, okay, where's the catch? Like, it can't be that easy, can it? And the answer is, yes, it can. Because they ask a nice, easy question just to ease you in, get the nerves out of the way, get you nice and settled, see you into the interview well. So obviously I draw a sine graph and I'm explaining along the way. It's not sketched perfectly, but this is supposed to be symmetrical. Label the axes just to be good. That's going to be a pi, that's 2 pi, minus 2 pi, goes up to 1, goes down to minus 1, the end. That's sine x. So then he says, okay, how about this? Y equals sine squared x. I was like, well, okay. Well, I'm going to draw my axes again. And then I said to myself, okay, well, I know what squaring does. It takes all the negative values and it turns them positive. So these positive values are going to stay positive and these negative values are going to become positive. So it's going to look like that. And that's going to be 1. So then he says, oh, that's curious. Tell me what's happening around here then. What's the sort of gradient doing around there? I went, okay, let me find that out. So to find out the behavior, let me take the gradient. So I'm going to do dy dx. I know this is going to be chain rule, so that's going to become 2 sine x cos x. And I know when I plug in x is equal to pi, that will be sine of pi, which would be 0. Okay, so actually, because the gradient is 0, that should have been a turning point. So let me go in and correct that. So then I redrew it. So it should have been turning points there. Nope, I've drawn that wrong again. Okay, let me try, because of course it went through 0 as well, so it went something like this. And he said, very good. Okay, so I'd made my first mistake. I'd survived my first mistake. We move on. I can't remember all the questions because, like I say, this was a sort of general interview. It was lots of these very short questions, going through lots of the math and the physics because I was actually applying predominantly as a chemist. Which ended up being a huge mistake, just for the record. Like, I got there. I'm so glad I did natural sciences because within 6 weeks I went, I hate chemistry so much. But hey, I got in, everything was fine. So this first interview was more the math and the physics to make sure I was well-rounded enough to handle the natural sciences course, not just being a chemist, you know? So there were lots of these itty-bitty questions. I remember vaguely that there was one about a slope, a ball on a slope, and what happens when when the slope is really small, and then obviously you kind of ignore air resistance and do all the slope stuff that you do in mechanics all the time. And then he asked an interesting question, which was, what happens if the slope becomes 10,000 meters high? And I was like, well, obviously you can't ignore air resistance anymore, something terminal velocity. So it was all very syllabus based. But then I remember it felt like it was going really well. And then right at the end, he asked me this question, which I will never forget. And it went, you have 2 identical metal spheres, identical in every way. One is hanging from above, hanging from a string, and the other is supported from below. And it's not able to move, so it will not fall off that support. These are completely thermally isolated, so all the heat energy that goes in, none of it gets radiated out. None of it is passed by conduction to the supports or by convection to the atmosphere. You give them both identical amounts of heat energy. And yet they do not raise by the same temperature. Which one raises by a bigger temperature and why? And I sat there and I was like, okay, didn't really have any idea. But I was like, okay, I know I'm supposed to show what I do know. So, okay, so Q equals MC delta T, but the Q is the same and the mass is the same and C is the same because they're identical and they're made of the same metal. So like delta T should be the same. And then I went through every option. I went, okay, it can't be radiation. He went, no, it can't be radiation. I said, it doesn't go into the wire or anything. He went, nope. And I sat there and I panicked and I went, oh my God, I not only can I not get this, I don't even know if I have what it takes to get this. Like I'm stuck and my Cambridge chances might be done now. And when they see you struggling like that, that's when they kind of intervene, kind of offer you a lifeline. So he says to me, well, what happens when you heat a metal? I went, oh, it expands. And then just like that, all the dominoes fell into place. And this is going to be a direct quote. This is going to show like how nerdy and sad I'm not sad. I'm very proud of this. But I literally like, as soon as I said, oh, it expands, I saw it. And then I went, oh, that is so clever. Oh, what? That's crazy. And I like started freaking out and having this like huge moment with it. Interviewer starts laughing. I'm laughing, but they're like, okay, you got to prove it now. You got to actually do the work to show it. And I was bouncing up and down with energy at this point because I'd seen it. I got it. And I was so like excited by that because what I'd spotted is when they expand, they'll expand differently. This one will have to expand downwards because it's being held from above. And this one will have to expand upwards. This is an exaggeration, obviously, but this center of mass is going to drop and this center of mass is going to raise, which means this releases GPE, and this you have to put GPE in to raise the center of mass. So I recognize, oh, okay, this one is going to raise by less. And the reason why is because the Q that you put in is not just going into raising the temperature. Some of it is also going into raising the GPE. So less of the energy is available for raising the temperature. And here, the GPE you get out goes into raising the temperature, so you get a little bit more. He said, very good. And that was, I remember, the final question in my first interview. So I was really pleased I got through that. And then I went into the little waiting room. And no one ever talks about this part. So I think it's really important that I do. But because I felt it had gone really well, I had the adrenaline come down. I kind of like was in it for the first one and I kind of relaxed. And I had a bit of a time to wait for my second interview. And then my second interview is in this guy's living room with the radiators cranked up, sitting on his nice comfy sofa. And I distinctly remember getting really tired and thinking, for the love of God, do not yawn. If you yawn, it is game over. So I think it's just funny how those sort of experiences can kind of get in the way. And it's not just about, the science in the interview, but it's also about what's going on in your body and what's going on with you psychologically and how that can, affect your performance. And so I sat down for the second interview, and this was my chemistry interview. And this was with a guy called Peter Wuthers, who has public profile. He's done the Cambridge, like a Christmas lecture series. I can't remember what it's called, the Christmas something. He's a big dog. He's a big name. And he's written a book that's recommended reading for anyone going for chemistry for Cambridge. It's called Why Chemical Reactions Happen. Phenomenal book, by the way. I learned a lot from it. And so I sit down with him, and he says to me, have you heard of the Arrhenius equation? And I say to him, yes, I read about it in your book. Because his book was literally like the cornerstone of my personal statement. And he didn't know. He hadn't read my personal statement at all. So when people ask, how much does the personal statement matter? I'm like, it depends. If you after the first interview, they say, if you make sure you've read something, if you say you read it, so they had clearly read the personal statement, but the second guy hadn't even looked at it. Not at all. So kind of takeaway from that is you're just kind of getting the interview. Whereas Imperial might base it entirely on your personal statement, or maybe a lot of personal statement into some other stuff. The Cambridge one, it's more standard. Like everyone's kind of getting the same thing. They'll push and pull a little bit to sort of find your like limit of your understanding. So if you're getting them too quickly, they'll make it harder just to sort of see what it's like. But on the whole, everyone's getting asked the same stuff. So he asked me, do you know the Arrhenius equation? I say, yes, I do. Rate of reaction. I say, well, okay, the rate of reaction is equal to K times the concentrations raised to some powers. And I know that the Arrhenius equation has to do with this K, this constant. And I know that K is equal to A naught e to the minus EA over RT. You can see my chemistry brain's a little bit stressed because I haven't done it so much recently. But the point here is, it didn't matter if I didn't know it. He was going to teach it to me. Because it's a lesson, not a test. Because not everyone learned the same stuff going into an interview. They need to make sure it's accessible to everyone. So they purposely tailor the questions to make sure that everyone will be able to do it regardless of their academic or educational background. If you don't know something, they'll present it to you. And even if you've never learned it before, you can still apply that idea in an interview and do well. Because it's a lesson and you can show you can learn. So it's an opportunity for everyone, regardless of what you know going in. So I see this Arrhenius equation. He says, okay, cool. Sketch it. We're going to sketch it for, we're going to do K versus 1 over T. And I'm like, okay. And it was weird to me because obviously I was expecting T to be on the x-axis, not 1 over T. And I was like, okay, well, let me rewrite this. So that's minus EA over R times the 1 over T, which is on the x-axis. So it's exponential to K. So I'll draw it as exponential to K. And I know I'm not going to draw a negative because you can't have negative temperature. So that should be A naught. And it decays to 0. And then we wanted to talk about that behavior a little bit. So he said, okay, well, what happens as temperature tends to 0? And I said, oh, well, as temperature goes to 0. And he says, no. As temperature tends to 0. And I went, oh, as temperature tends to 0. I probably shouldn't have done that. But like I say, I was kind of cozy and tired and warm and was kind of backsassing him. He kind of loved it. Like he had that kind of confrontational vibe, which I think I was picking up on. But I don't necessarily advocate for backsassing your interviewer, but I did, and I'm just being honest about that. So I said, as temperature tends to 0, then 1 over T is going to tend to infinity, and it's going to decay away to 0, which means that K is going to tend to 0. And they say something like, does that make sense physically? And I went, yes, that does make sense physically, because I know as the temperature goes to 0, the particles lose their kinetic energy goes to 0, so they're not moving. So they're not colliding. So there's no reaction happening. I expect the rate to go to 0 as temperature goes to 0. So yes, that makes sense. And what about when temperature tends to infinity? And I said, okay, well, 1 over T is going to tend to 0. So K is going to tend to A naught. And I think a lot of other conversation happened then about, well, I think, no, he also got me to sketch a graph of ln K versus 1 over T. And so if we're going to do ln K versus 1 over T, let me rewrite this just so it's fresh and clean. So if K is equal to AE to the minus EA over RT, let's take natural log of both sides. You'll get ln of A minus EA over RT, which I'm going to write in this form. So clearly this was going to be a straight line equation, y equals mx plus c, where the gradient is minus EA over R. And so I did that. And then I asked myself, hang on a minute, can it actually go negative? Because that never goes negative. Can this go negative? So let me just follow through what I knew. Okay, well, first of all, that is going to be ln A. It's going to be the intercept. If that's 1 over t, labeling my axes, that's going to be ln k. The gradient is going to be minus EA over r. And then I asked myself, can that go 0? It would be 0 when EA over r 1 over t is equal to ln A. So yes, that can happen. There will be an actual physical temperature at which ln A goes to 0, because that's when A is tipping through the value of 1, because ln 1 is 0. So that's totally fine. And we have this nice thing with a nice negative gradient. I can't remember the whole of that interview. It was half an hour long. And I think the conversation went to some really weird places. And this was the entire half-hour interview, whereas the first one was sort of bouncing around all over the place. This was an entire half hour just on this one equation, just on this one graph, and all of its implications. Like, we talked about, I remember asking a follow-up question, like whether the gradient, I think he mentioned offhand at one point, well, the gradient could be, I said, there was something about the fact that, well, the gradient has to be negative because the activation energy has to be positive. And I remember he said something like, oh, there's some equations or some reactions that have negative activation energy. And I was like, what? That makes no sense. And so the conversation kind of talked about that for a little bit, but the entire thing was just on this. And then it was over. I felt it had gone well, and that was the interview process done. So what you can see, first of all, let's talk about like how I did and the things I think you can take away for any interview process. First of all, heavy reliance on graphs. Lots of graphs in the first one. The entire second interview was based on graphs. Graphs come up all the time. So every time I do a mock interview, I'm making someone sketch something, because there's lots to test in a graph sketch. And I'll go through that in a bit. Another big takeaway, don't be afraid of being wrong. I was wrong here. The point is to just get corrected. They won't say, oh, that's wrong, it should be leveled and curved. They'll just sort of ask an innocuous sounding question like, what's the behavior around there? Sort of light touch nudge to get you to get yourself all the way to the correct answer, to get you to spot your own mistake, because they don't want to interfere with the results of their own experiment. If you're getting the right answer, they don't want that to be because they dragged you there. They want to make sure you're going for glory and you have the opportunity to demonstrate what you know. So they'll ask very innocuous questions. Try not to intervene unless absolutely necessary. Oh, apologies. I'm just going to drink a little bit of water. Sorry about that. So, graph sketching, hugely important. Making mistakes, totally fine. They'll give you a light nudge, spot it, correct it, move on. You got better. And I learned something about how to sketch graphs as a result of that, which is why I know it went well, because that's the lesson. I learned something. This moment was just wild. It was, and if I want to explain it though, when you heat a metal, it expands. When something goes up, its GPE raises. That's all this question depended on. So it was actually really simple physics, but in a way I'd never seen before. I didn't have the slightest clue how to approach it. And in situations like this, the best thing to do is to demonstrate what you know, try and get there. So that way and by talking out loud the whole time, you've demonstrated it. So they're not sort of, the worst thing to do in this situation is to sit there in silence. Because if you sit there and you go, I'm only going to start speaking when I come up with a correct answer. And you sit there quietly trying to do all that in your head. They sit there, from the outside, that looks no different than they can't tell. The reason to talk out loud is to show the difference between I'm trying and not getting it, and I just have a brain that doesn't work. So that's why you kind of do everything out loud. And if they need to throw you a lifeline, they throw you a lifeline. And the point is to, whenever they are intervening, and you've seen that in all of these cases, I was getting constant intervention about how to do this. And the point is to take those hints and to run with them, to realize that they're not going to give you anything that's super direct, but they're kind of like wink, wink, nudge, nudge, and kind of get in their head and like, all right, why are they saying that? Pick it up, see how it can be applied to the question, and work your way forward from there. Okay. So that is kind of how my interview process went. Feel free to drop a comment if you have any questions about that specific experience. But what I want to do now is to talk about two things. The first is how I go through my mock interviews with people, what types of question I try and prepare people for. And the second is to go into what resources you can use to prepare yourself. So in terms of type of question, I kind of break it down into the following 5. So the first one, graph sketching. You can see that came up a lot in my actual interview, and graph sketching from feedback comes up in like every interview. So making sure you can, and that's pretty much all combinations of polynomial, exponential / log, and trig, and like combinations of them. And I'll like, as we go through, I'm going to be doing one a week of these, and every single one I'm going to do some graph sketching as part of it. So I'm going to demonstrate all the weird and wacky ways you can go through it. But the main thing is when you're doing your graph sketching, as I'm here, there are certain things they're looking for, which is what are the intercepts? Where are the turning points, if there are any? Where are the asymptotes and how do you find them? So usually you can find them, for instance, if there's any divide by, are you ever dividing by 0 so to find the vertical asymptotes? Or to find the horizontal asymptotes, considering the behavior as x is tending to infinity or minus infinity. That kind of stuff. And also, do you have any predictions about the general shape? So if it's a simple polynomial, for instance, you do. So all of these things, and also if there are any special points of consideration. Which haven't been mentioned by the above. So then another type of question you might get, well, let me get rid of this. Nope. Okay. So the second type of interview question is just basic syllabus stuff. This is just much more in hand. They're testing the fundamentals to make sure you know what you're talking about. Do you know how to sketch sine x? Can you solve simple equations, EVs, that kind of stuff? So you might get a bunch of rapid questions like this. Oh, okay, let's set the kinetic energy equal to the gravitational potential energy. Do that. Let's do ball on a slope. Very familiar types of question that you get in the textbook all the time. So the third type is what I call like a developed idea. So the developed idea is one where they start you off easy. They might teach you something new. And then they'll get you to apply that new idea in a new way. And then they'll push it, what about this? And what about this? And so this is very much them. This is like all about learning and applying. So this is something you've never seen before. And because you've never seen it before, they can't expect you to know it. They have to teach it to you. They start you small, they build you up. And they want to see what it's like, how quickly you can get up and running with the new idea. Another type of question is what I'll call derivations. So this is a question which is doable from the syllabus, but it's harder than the basic syllabus question. It's a new situation. It's one you haven't seen before, and you kind of have to think really hard about how all the stuff fits together to come up with a new derivation. And then to test whether it predicts something physical. So you might derive, like they might give you a wacky situation where they say derive this distance x And then they might say, what does that mean physically? Does this make sense physically? Does this predict something physical? And the final type of question is just the open question or the out there question, which for me was the metal spheres question. I just looked at that and I went, metal spheres, yeah, one of them raises by less temperature, go. And I was like, you don't even know where to start. Don't know where to start, don't know what to do, no sense of guidance, no sense of direction. And it's just a case of fumble your way through and see if you can piece something together. But that's the point of the question. A lot of times people look at these fifth type, the out there questions, and think, oh my God, I'm failing. Oh my God, this is going so badly. Oh my God, he's judging me so much. It's like, no. This you fumbling around in the dark is why they have given you the question. And so it's all about trying to come up with some system to answer the question, demonstrating what you know from the syllabus, how you think ideas connect, taking on board when they give you an intervention, and also seeing if you can handle like more complex problem solving. So problem solving that might be multifaceted. So a question I've seen on YouTube, for instance, is what happens to the efficiency of an engine in the rain? And there's just a number of approaches you could take. You could talk about how the density of the air increases, and so that means that the increase in momentum going from 0 to fast when the air is propelled out means you get more force from that because the change in momentum is greater. Okay, but what if it cools down the temperature of the engine and thus makes it less efficient from cooling it down? And what happens to the weight of the water? So it does this. There's like a lot of places you could take it. And so it's more of a conversation then, rather than a simple pen to paper equation, just to sort of see how you grapple with different ideas and can apply them to sort of real problems in the real world. So as I'm going through my interview series, these are the types of questions I'm going to point out. And in any sort of analysis after the fact, when I show you questions that I've come up or I've pulled from different resources, I'm going to analyze them in these terms. And then finally, I think I want to show you what you can do to get yourself up to standard. So what are the resources you can use? Okay, so I think good resources are ones that have Oxbridge level math or science and long form written questions. And luckily, a lot of that material already exists from the entrance tests before they changed everything up last year. So you might want to be looking at the PAT test. This is a big source of interview questions for me. And in fact, some of them I'll go in specifically and show you my favorite questions, apply those in an interview way. So you might want to do all the PAT tests if you haven't done those yet. I recommend NSAA Section 2s. You can try the multiple choice ones. So the way that works is pre-2020. These were long form, and they were very good. Giving more of a developed question, as I called it, where they introduce something and they get you to sort of piece it together and make it more and more complicated. And post-2020, they are multiple choice, but they are still really interesting concepts where you can imagine they could ask it just without the multiple choice element. And I've got these up and running, so I'll show you what I mean on these as well. So these are the main two in terms of like the science side of things. NSA, you also obviously have the chemistry involved if you want the chemistry. Other resources I think are good. I want to study engineering. I know is one that is recommended to a lot of engineers. It's one to put on your radar if you are also applying for physics. I will caution though, these are not specific for Oxbridge entry, and so they're not necessarily pitched at the same level. And a lot of the questions that I've seen have been very, very, very challenging. So if you can be tackling those to a high standard, that's how you know you're doing really well in your interview prep. But if you're finding that too much of a challenge, it doesn't mean you're failing. It just means they're really hard. Also, they might be fun to grapple with on your own, but in a high pressure situation of an interview, it may not be realistic to sort of get there on those types of questions because that's just a whole different kettle of fish. Another thing I recommend, the British Physics Olympiad, round 1 papers. So in fact, let me show you. So the BFO round 1 past papers, you can find them here at this website. A lot of these are very, very good. And there's one question in particular you can see in this 2020 that I think is just absolutely perfect. Oh wait, I haven't shared my screen yet. Hold on a minute. No, I have shared my screen. But I've only shared that tab. So okay, let me stop sharing that screen. And I'll start. Let me just do the entire window. Because that way when I switch tabs, it'll be fine. Cool. So we can see here, moving from so resources for interview prep, BFO round 1, you can find them at this website here. I've already gone into 2020. There's one very, very good question in there, but I'm not going to show you now because I'm going to save that for a future week. Go through that and show you why I think that's very, very well suited for interview. PAT tests, you can see I've just like gone through them because I've got someone who was doing the PAT test. But the PAT test questions are very good, usually, especially like in the modern era. If we go into it, obviously all publicly available. Multiple choice are good for the math, but I think these long form ones are much better. Not so much that one. Yeah, something like this. Very open. You don't need to rely on a calculator. It's all about deriving expressions, and then you can analyze the expression afterwards and kind of think of it as good. So these very open questions are good to get you in the mindset of interview. So you can go for PAT, showing you the NSAA, old style section 2s. I absolutely love this first question. It's so interesting. I definitely recommend getting into all of these. These are a bit more calculator based, so they're not dead on the money, but conceptually they're still very interesting. So this one talks you through the idea of having particles go through a slit, and because they're both rotating, by the time it's arrived at the second slit, the slit has rotated into position such that the particle can go through again. So kind of the first one goes through, and then it rotates, and then it's going through the second gap, and talking about different speeds that will achieve that, and then developing it through and talking about what happens when you do the same thing, but it dropping instead of going at a constant speed when it's accelerating through. Really interesting idea for like developing it. So you can get into these, and same thing here with like, okay, they introduce these circuits, and then they do exactly the same thing, but this time they have internal resistance. And they start off easy and just turn the screw. And these are good at these, what I call these developed idea questions, the NSAA papers. You could also go through the Angus section 2s. If you wanted. These are also multiple choice, but you have some written answers in them as well. Anything that's basically a high level of Oxbridge level physics that you haven't already done in your ESAT or PAT prep, really good. Showing you I want to study engineering.org. You can have a go at choose from over these 200 problems. So yeah, but definitely really challenging. So no pressure if they're not sort of great for you. One thing I haven't prepared actually that I'm going to stop sharing just as I get the tab ready. But another thing you could do is if you're focusing specifically on the math side of things, because you will always get math questions. And you've seen that especially with like the graph sketching, those sorts of things might come up. A good resource for that might be the MAT test. So I'll share again. I'll share the window. Not that one, this one. So this is sort of less applicable now, but you might throw the MAT test in there for two reasons. One, the multiple choice is very good at testing sort of your broad mathematical ability. So these are much more in-hand questions of the type they might ask you. Would you look at that? This is about graphing and about cubics having two distinct stationary points. So these sorts of things that come up again and again and again in science interviews. But another reason why I think these are very, very good is they really stretch your brain. And of all the papers I've seen, apart from maybe if you're doing IB, AA, higher level, paper 3 is a very similar thing, where they introduce an idea and like develop it through, where you're meant to have half an hour for the question. And this is exactly what the exams at the end of each Cambridge year feel like. You get 10 questions on the paper. You have to answer 6. You have 3 hours to do it. So every question is half an hour. And I cannot tell you how much it feels like a MAT test. So the MAT test might get you into the head of the Cambridge experience of starting off. You never studied this. You don't know what this is, but you test it with a simple premise, and you develop it a little bit further, and you develop it a little bit further, and by the end you're doing some crazy nonsense. So again, that can be really good to get your brain into the habit of this question, this type 3, learning a new thing and applying it in a new situation. So there's plenty for you to be getting on with. And also what I will say is if you are going to use the MAT test, this is more for like general thinking skills. Question 5 and 6 they're the ones that are for the people applying for computer science, and they're very logic based and sometimes very, very fun. So I want to see if I can find the can I find the one with there's one where there's a question 5 which has to do with like a game I absolutely love. Yes, I absolutely love this question. I mean, it's so off-putting in the real thing because the question takes up the entire page. But here, there's this like really fun idea of like, well, I'll show you the I can't answer. Yes, I can. So the way it works is you have doors, and once you pick a prize in the door, the host will swap it. So if I pick this door, for instance, I get that prize, but then he's going to swap that with one of the ones next to it, but you don't know which one. And then you open another door. And if you get the same prize, womp womp, sorry, you don't get a new prize. But if you're strategic about it, you can pick up lots and lots of prizes. So I won't go through the full logic of this because it'll take like a full half hour to do in really good detail. But they say, oh, come up with a path of length 7 for the specific case. Oh, well then come up with a general case. Then for the specific case of n equals 13, how about a path of 10? How about 10 doors? And then why don't you generalize that for all n instead of just n equals 13? Oh, and then this is going to get really tricky. So let me give you the idea. Let's test it out for n equals 3 and test it out for n equals 5. So then, now that you've picked up on how that works, why don't you do for n equals 13, 11 doors that will get you new prizes? And why don't you generalize that? And so this can get you in the head of like starting off with something that feels brand new, but then getting your brain stretched so that by the end, you're really able to tackle it. So it's bananas. Again, none of this is like, this is more for like, just generally getting in the right headspace for it. I would say in terms of stuff that you have to get, I would say PAT tests and NSA papers are really good for making sure like the syllabus material is where it needs to be. And just like it was for the PAT test or the ESAT, syllabus mastery is the name of the game. Making sure you've got all of your syllabus stuff really up and running so that when someone lobs you something weird, you have the tools at hand to sort of go hacking through the jungle and finding your way through. So I think that about wraps up what I wanted to do in this first session. Talk about my experience with it, show you the resources you can use on your own, and show you how I'm going to break out my interview questions with the series to come. I'm planning on doing 1 hour at a time for each of them. I think, let me check my calendar, because we're in half term now. So luckily I've got some time in the evenings, but I know when I go back to regular schedule, it may be on a Wednesday like today, but I think it's most likely going to be Thursday evenings. And for the interview stuff, I'm going to make sure I do it in the evening so people can actually tune in live and ask any questions. And as I'm learning today, people actually do that sometimes, and they actually leave comments. I will actually read them and act on them. So that's the plan. I'm going to sort of be playing both sides of it. So I'm going to be interviewer and interviewee. And I think with them, I'm going to show what I think the most common mistakes are and how to kind of get around them. So hopefully all of that makes sense. I mean, the one thing I'm definitely demonstrating is the ability to talk out loud because I'm like filling all of the space. But I think that skill, if you can even talk it through with anyone, that's the one that's weird to people. That's the one that's unpracticed. And that even if you have like a study buddy, teaching it to them, talking them through it, explaining it to them, guiding someone else through your thought process, anything you can do to practice that muscle would be really good for you so that when it comes around to the interview, you're used to that style of explaining yourself. Okay, so I'm going to wrap up. I think everything I'm saying now is cumulative. Y'all are smart people. You know what I'm doing now. So I'm going to probably post in the community tab when I've decided on a fixed schedule. I'm going to populate the streams ahead of time so you kind of know when they're coming in case they're off schedule. And I'm getting close to setting up a proper sort of public-facing website with an email. So when it comes around to it, hopefully I'll have a system in place with like good safeguarding and dotting all the I's and crossing all the T's to make sure I might be able to drop in and do a few actual interviews with people if that's something that anyone wanted to do. All right. That's my hour up. With that, I'll leave you to it. I think you know what you're doing. I'll see you next time. Work hard, have fun. I'll see you then. All right, thank you for the two of you for actually sticking around. Yeah, let me know if you have any suggestions. I'll try and tailor it to the people who are here. And hopefully see you next time. All right, take care. Thanks.